All right, this is Calculus Chapter 1, Lecture 2. We're still just on introductory material to try to explain, the purpose of calculus. So we're going to get into that question 1, instantaneous rates of change. And let's draw our bicycle situation again. So we've got 0 miles, 30 miles. Got our bicycle. All right, and our speed limit sign at the 20-mile mark. And the speed limit is 20 miles per hour. Just so happens to be at the 20-mile mark. So we said the total time, 30 miles in 1.5 hours. That's how long it took. So the question is, was he speeding at the instant that he passed the sign? Okay, we know that rate equals distance over time, but that is not the whole truth there. It's actually the change in distance over the change in time. That's how you get the rate. Okay, so delta D, change in distance, delta T, change in time. So in this particular case, if we look at the whole journey, our rate is going to be 30 miles over 1.5 hours. All right, and that's going to be 20 miles per hour. But that actually doesn't answer the question. That's just the average rate of change. Algebra will give you that answer. So that's not telling you what was his exact speed at the 20 miles an hour sign. That tells you what was the average rate of change for the whole trip, what we just did. So let's write that down. This doesn't answer the question. $20 miles per hour is the rate or the speed for the entire journey. We still don't know the rate at the instant of passing the 20 miles per hour sign. Okay, so at the instant of passing the sign, we have rate as change in distance over change in time. Well, what's the change in distance from the sign to the sign? That's the instant of passing the sign. Well, that change in distance is 0. 0 miles. What's the change in time from the signpost to the signpost? Well, it's instantaneous, so it's 0 hours. Well, that's 0, 0. What the heck is that? Dang. That is a conundrum, right? 0 over 0, maybe you think, well, that could be 0, right? Or 0, 0, like if it's another number, like 5 over 5, that's 1, right? So could it be 1? All right, could be 0. I don't know. Could be 1. Well, it's actually not either. When we have 0 over 0, So I'm going to take a moment to erase here and start back up. I'm not going to erase our bicycle line though. 0 over 0 is not a number. It's indeterminate. So we call this indeterminate form. The equation can't be solved with algebra. So we got to come up with a new form of math to try to figure this out. So instead of trying to substitute exact values which is what algebra wants us to do, calculus will let us inch up to the answer to see what the rate gets arbitrarily close to. All right. So let me see if I can show you mathematically what I'm talking about here. Okay, so I'm going to erase this. You go ahead and draw the bicycle line again. So you'll, and I'm not going to draw it again, but you draw it again underneath this. And let's see if we can inch up to the value. Let's see if we can approximate it. So since we can't, that's a big old apostrophe there, isn't it? Answer this question exactly, because we get a 0 over 0. Let's try to approximate the instantaneous rate. All right, so we're going to make some guesses and see if we can figure out the answer through process of, just inching up closer and closer to the answer. All right, so we can try to find the average rate, because we know how to do that, right around the 20-mile-an-hour sign. Like real close to it. Not exactly on the post, but just to each side of the post. But in order to do that, we need to know the biker's position at various times. So let's say this biker's journey was modeled by a satellite, okay? And they were able to collect all sorts of data and come up with a position function, meaning at any time we could figure out where the biker was on this journey by P of t, remember this is just the fancy way of saying y, all right, but P of t is equal to 40 over 3 times t squared. So let's say we knew that's the way that the bicyclist travels. Plug in any time between 0 and 1.5 hours, and you'll figure out where he is, at what is the mileage point, all right? So, for example, let's plug in P of 1.5. Well, it should be 30, right? Because at the end of the journey, he's at mile 30. So let's just make sure that's true. 40 over 3 times 1.5 squared. And you can put that in your calculator and see if I'm lying, but if you'll put that in, it is 20 miles. Excuse me, 30 miles. All right. So let's find, so instead of finding position, let's find the time at 20 miles. So we could do that. We could just, for P of t, plug in 20 and then solve for t. So 20 is equal to 40 over 3 times t squared. So solving for t, that's going to be the square root, if we flip and multiply, of 20 times 3 over 40. Right? Square root of 60 over 40. And that is 1.225 hours. That's what your calculator will say. So we know at the 20 mile an hour sign and 20 mile mark, it's 1.225 hours. All right, we're going to erase that, and we're going to pick another point close to the sign. All right, let's pick a time near this. So let's pick a time near the sign and get position. Okay, instead of 1.225 hours, I'm going to pick 1.2 hours. So let's pick 1.2 hours. That's close to 1.225 hours. So we know that P of 1.2 hours is going to be 40 over 3 times 1.2 squared. Right? Our position function, I'll write it out again. P of t is 40 over 3 times t squared. That's where's the bike going to be at a particular point in time. Our point in time is 1.2. So you plug that into your calculator, you get 19.2 miles. So now we know that the rate is change in distance over change in time. I can get an estimate of the rate by using these four numbers. The change in distance would be 20, right? At the 20 miles an hour sign, we know it's 1.225 hours. So 20 miles per hour minus 19.2, excuse me, this is miles. 20 miles minus 19.2 miles over 1.225 hours. That's the time at 20 miles. Minus, and this, by the way, you might remember from physics chapter 1, is just a slope. Minus 1.2 hours. All right? It's 1.2 hours at 19.2 miles. All right? If you put that in your calculator, you get 32 miles per hour. So that's an estimate. That's an approximation. Of the speed or rate at the signpost. All right, we got ourselves a guess. It's not exactly correct because they're actually 0.8 miles apart. So our first time is 0.8 miles back this way. So actually not a very good estimate, okay? But what if we inched up even closer? Okay, so we're going to inch up closer. I'm going to just erase, you just keep going down on your paper. I'm going to give myself a little more room here. And let's pick another position. Okay, so I'll go ahead and erase that. How about, let's write this out. If we analyze times and distances extremely close to each other, we can get an instantaneous rate. And I'll give you a clue where we're headed. We're headed for the distance to be infinitely small. All right, infinitely small. But we're not quite there yet. So let's try a closer point. Let's try not 1.2 like before, but 1.22 hours. That's really close. That's only 5/1000ths out of an hour away. So that just a few seconds there. Okay, maybe less than a second. I'm not sure. I'm not gonna figure it out. But P of 1.22. All right, so we'd have we've got 40 over 3 times 1.22 squared, right? That is 19.85 miles. Now that's still 0.15 miles away, but we've gotten it closer. Last time we were at 0.8 miles away, so we're getting closer. All right? So rate is equal to change in distance over change in time. So that's going to be 20 minus 19.85 miles over 1.225 hours. Remember, the 1.225 goes with 20. Minus what goes with 19.85? 1.22 hours. All right, so that's going to be 0.15 over 0.005, and that is 30 miles per hour. Now, that is not the exact rate of change, but that is a better estimate. Why is it a better estimate? Because we're getting closer and closer to the signpost. We're taking our difference and squeezing it in. Okay? What if we went to a billionth or a trillionth? Then we'd be getting really close. All right, that's going to be, there's no homework tied to this lecture. I'm trying to keep these introductory lectures kind of short. And we'll move on, we'll talk about lecture 3 and discuss the concept of the limit on the next lecture. All right, thanks and see you next video.